So for problem 2, basically we have money in different countries, including Japan, Indonesia, and Malaysia. So we would like to transfer all these monies into US dollars and try to minimize the transaction cost, which is and we are constrained by the transaction limits. Firstly, we convert all the currencies into US dollars. So for Japanese yen, we have originally we transferred 15 million US dollars into Japanese yen, and at that time, that was like 120 million yen, and then we would like to transfer it back to US dollars, but now the Japanese yen only versus our 120 million Japanese yen only versus 9.6 million US dollars. And for the Indonesian rupiah, we have 10.5 billion. So multiply it by 1,000. It's this is the million value, and then we apply the transaction, the exchange rate, and we have 1.68 million US. That was 1.68 million US dollars. And then for the ringgit, with similarly we apply the exchange rate, and it was 5.6 million US dollars. And the demand amount is the sum of these supply amounts. So here, every unit here is 1,000 US dollars. So here are the supply nodes, the demand nodes, and they have their supply and demand values. So for each arc, the number in the front is the percentage of the transaction fee. And then this is the this is the proportion of the transaction fee for every 1 unit US dollar transfer. And here, this is the limit of the transactions. So for every supply node, it can transfer to the node in the middle, the demand node, and even within the supply node themselves, because sometimes it can be cheaper for let's say Japanese yen to transfer into Indonesia first and then transfer to other nodes. Then it transferred to other nodes and then to US dollars. This may be a possibly cheaper way. Yeah, and that's it for the graph. So in question B, we would like to form the problem, and here we minimize all the transaction fee, transaction cost, every unit multiplied by the amount of the unit this arc transfers. And these three constraints are for the supply node. Here is the arc pointing into it, and here is the arc pointing out of it, and their difference should be the supply amount. And here, these are the nodes in the middle, so the arc pointing it minus the arc pointing out of it should be 0. And for this is the demand node, so it should be equal to this value here. And here are all the limits values, if they have limit values, of course. And they should also be bigger or equal than 0. So then I implement it in the IBM Cplex. So here it is. For the mod file, all the problems in problem 2 share the same mod file. It's the one we used in our homework. So it's the sum of the. We want to first we want to minimize the total flow here, minimize the total flow, and then we want to sum all the arcs, and the arcs should be they should satisfy the supply and the demand amount, and they should also subject to their upper bound. So let's look at the data file. So here is the from Japanese to C, which is a node, and then the cost and the upper bound. Upper bound is the transfer limitations. For those who don't have an upper bound, I have a very big number for it, and that's it. So let's see the yep. So this is the answer that it produces, and this is the optimal Z here. And so it also asks the money transferred into US bonds. So this value equals to the total demand we have minus the cost. So this means that real value of the money that be put into the US bonds. And then in the problem C, we remove the limitations due to the free market. So just in the implementation, all these upper bounds is a very big value, and the others are the same. So the optimal object value is smaller compared to the one we had before. And for problem D, so for problem D, it changes the transaction cost from or to Indonesia here, from Indonesia and to Indonesia, by increase it by 500%, which means multiply it by 6. So here in the implementation, so all the nodes that have IR in it, which is have their cost multiplied by 6. So this one from Y to IR, and all the IR and this one, I multiply them by 6. And let's see the answer. The answer here is becomes bigger again because of the increased cost. And so for the problem E, what should we consider? First, it's so in the problem it says that invest money in the US bond is safe in this current market, but is it really a good plan or a safe plan, or do we have like some better plans? And the second is that so we only have 8 countries in this problem, but is there? I believe that there could be like other countries can be transferred in or out and make the uh, have lower transaction cost, and so we should take this into consideration too. And the third problem is that so our transaction may be last like 4 days or 4 weeks. So during this period, will the transaction cost and the exchange rate change? Um, that will affect our decisions. So we should take this into account. And that's it for this problem. Thank you.